Hello, welcome to this OceanPrediction Decade Collaborative Center meeting. Today is the last session of the regional team meeting for the West Pacific and marginal seas of South and East Asia. I'm Marie Drevillon from Mercator Ocean. I will chair this session, and we will start with a session on marine litter with a talk from Young-Gyu Park from KIOST. Please. The floor is yours.
Good morning and good afternoon. And again, thank you for inviting me to here. Today, I will be talking about how we could use product from many agencies about ocean circulation and atmospheric flow, as well as satellite. So this is a work myself and my collaborators back in Korea. So here I will try to explain how we could improve Lagrangian particle modeling results using satellite. So this is the content. I will explain motivation, and I will try to explain how we could combine particle tracking model and satellite data through two case studies. First one is about flood-induced debris. I will probably mainly focus on the first part. The second part is about floating volcanic rocks, and I'll be talking about this in 2 weeks in Busan. So there are diverse floating objects in the ocean. First one is an instrument we are using to measure the ocean. Actually, this is a wave buoy deployed southern part of Korea. It was hit by a typhoon and the line was cut. And it was floating in the ocean for about 5 years and finally found in west coast of US. And the ones at the bottom is microplastic and macroplastics. This is like a, it's everywhere. Another thing is more episodic event. The one to the top left is debris due to flooding. As you can see, there are big woods. So that could be hazardous to marine traffic as well as coastal tourism. The one at the bottom is from volcanic rocks in Japan. It erupted and produced lots of floating rocks, and that was hazardous to local traffic, harbor, and even fisheries. The one to the right, green tide and sargassum occurring Yellow and East China Sea. That occurs once in a while. Like those, the green tide and gold tide is a seasonal event. The one to the left is occurring once in a while, but the scale is quite large and it happens all of a sudden. So we need some sort of immediate attention. The plastics are everywhere, but we could endure to some degree, but this kind of thing could be very hazardous. So what should we do? First thing for the mitigation might be forecasting fate or destination of those. Maybe 10 to 15 years, if you want to do Lagrangian particle tracking model, you probably have to run your own ocean circulation models. But these days, there are quite a few agencies who are producing forecast data for the ocean and atmosphere. So you just go to some website and download the data. And even there are models for Lagrangian particle tracking. So you just download resources from here and there and could run a model based on the following equation. For this kind of thing, you just need to understand Python, few lines of Python and read manuals, and you could run your own model. This is a basic idea about Lagrangian particle tracking. Let's just say a particle is at some point at time t-1. That will be transported to a new position due to ocean current and wind. So somebody might say, when we calculate the ocean current, we already include the wind effect. So why do we bother wind again? So the easiest analogy would be sailboat. Let's say you have a boat with a small sail and you have a boat with a big sail. So the boat with a big sail will be affected by wind quite strongly. So that's something called a wind effect or windage. There are many objects, well-tested objects. So the windage of those objects are known, but there are some objects that are not tested well. Typically, windage for floating object is somewhere between 1 to 4%. In some cases, it doesn't really matter, but in some cases, the value really matters. As an example, I will show you later. So now you got data from here and there, and you run a model. And for this kind of cases, we want to use this for some mitigation activity. Then we need to check. We need to validate the model result quite correctly. So you could run a model and could produce movies. Well, the movie I made is not so good, but you could produce fancy movies. The question is it correct? First of validation is going out and make a measurement. But it's a once in a while event. And you cannot go out and make a measurement easily. And field test is not easy. You cannot do a field test using volcanic rocks. But thankfully, these days, satellites are everywhere. So we could use satellite to verify model results and improve those. So I will try to explain how we could do that through two examples. First one is for the flood-induced debris. In this case, we found the surrogate of marine debris from satellite images. And the second one is about volcanic rocks. In this case, we compared model results and satellite data to find optimal windage value for those rocks. So the first one is flood-induced debris. It's about 2016, at the end of August 2016, a typhoon landed near North Korea. There is a river along the border between North Korea, China, and South Korea, and that caused flooding, serious flooding. About 2 weeks after the flooding, debris start to show up on the east coast of Korea. So this shows ocean current and wind. There is a south-south current along the coast of Korea. So if you have a decent knowledge of oceanography, you would know that it's coming from the North Korea. And at the same time, there are some plastic bottles which has writings in Chinese and North Korean. So you don't have to run to see that it's coming from North Korea. But this kind of wood could be hazardous to the traffic, and some would be in the water. And if that hit the boat, that could destroy those. So this is hazardous, and we want to know if we could forecast this in advance. So the first thing we looked at was a satellite. Korea launched a geostationary satellite. It's a high resolution, so it's about 500 kilometers. So we want to use that first. But the debris is just a few meters at the most. So it's not possible to see those debris using the satellite images. So we want to find some surrogate. And our hypothesis was debris would move along with the flooded water. And flooded water contains mud from the land and also organic matters. That's called CDOM or TSS. So if we could trace that properly, we might be able to trace the debris. So those are the photos of pictures of CDOM and debris. Well, CDOM and TSS, basically those are the same. So I will mainly talk about CDOM. So as you can see, the circle represents the river. And you can see there are some reddish signal along the coast, and that's coming from the river. that's September 1st. That's the date for the flooding. And a few days later, you see some front moving southward along the coast, and 16th, the front of that CDOM went further down south. The problem though is summer is a rainy season. So the river is producing CDOM and TSS all the times. So does that a mean structure or anomaly due to the rain? So we decompose the signal into the mean and anomalies, as shown here. So on September 6th, if we look at the CDOM and if we look at the arrows, there's a front moving southward along the coast. So on September 20th, it got to South Korea. So we say, well, this is considered. So we say we could trace at least river, freshwater from the river using satellite images. Then will it be consistent with debris from the river? So we ran a Lagrangian particle tracking model. It's offline using HICOM and wind from the Korean Meraphis. So we deployed particles at the mouth of the river on the different windages, 0%, 2%, 4%. The reason for that is those household debris have various buoyancy. So some are submerged, some are floating. So we deployed various values. And as you can see, started from the river, Tuman River, and moved southward along the Korean coast. On 14th, it got to the point where we found the debris. So 14th, it got to the point where we found the debris. So it's consistent with the observation. And will that be consistent with the satellite observation? Well, the lines are a bit hard to see, but if you believe me, they are consistent. But the difference is CDOM is water, so it won't feel the effect of wind. So it won't feel the windage effect. So if we just compare 0% and satellite images, they are consistent. And the model also produce hotspots of accumulation. This hotspot is useful for cleaning effort. There are strong hotspots in northern Korea, but there is no way of confirming that. So this is one example. And another one, I'll go very quickly. About 2 years ago, underwater volcano was erupted and produced rocks. It's a pumice, it's a floating rocks, hazardous to marine traffic, harbor, fishery, and tourism. And in this case, in that area, ocean current and wind are in opposite direction. So the results is very sensitive to the windage value we are using. For example, for no wind effect, most will go to Japan. For higher windage, it goes south. Even higher, it spread much wider area. For mitigation plan, this is important. So for the mitigation plan, the windage value is important. So we modified previous studies comparing. So we compare the distance between Lagrangian particle from the observation and satellite images on the date satellite image becomes available. Yeah, satellite take pictures every day or every 3 hours or something like that, but that does not necessarily mean we have data every 3 hours. Cloud. So for example, we get data like every 5 or 6 days. So we made a comparison between, so basically we measure the distance between observation and particle tracking modeling and look at the sensitivity of the distance between observed particle and the modeled particle and found the optimal value. So that's 2.8%. This volcanic thing happens, but maybe once in 20 years or something like that. So if it happens in 20 years ago, use 2.8% for the particle tracking model. So yeah, so optimal windage is about 2-3%, and Lagrangian modeling could produce continuous trajectories. And these days, it's very easy to do that because the resources are everywhere. And satellite images, you also could download that from website very easily. And then you could compare your model and satellite data to tune the model. So they complement each other. So this is all I have. Thank you.
Thank you very much. Is there any question? Yes.
You mentioned about the river, so you have also a river model according to the ocean model?
No, river model. River model causes some discrepancy between satellite observation and the model.
Jan also has one. Whatever. Yeah. Maybe I start with mine. Okay. My question was about the currents that you use for your tracking. You shown at one point that it was HICOM.
Yeah.
So you need so you wanted to use tides, I guess.
Use what?
What was your motivation for choosing HICOM, and did you do tests with GLORIS 12? Because I know you are also using GLORIS 12. Was it consistent?
Yeah. The reason, I forgot to mention that the reason I was using HICOM is at the time it's the easiest one to download from the website. So ease of access and ease of use is also important matter. And we tested HICOM quite seriously, and it worked quite nicely. And now we are using also European product too.
I would expect that HICOM would give more dispersion because it has more energy than GLORIS 12 maybe. But it's Enrique or Jan? Okay, thank you.
Can continue in the same way as Marie. In your surface current product, do you have also the effect of the stock drift or the tide and the tidal current? Just because the windage could be also a compensation of this kind of processes that are not most of the time included in the system. So I don't know if in your simulation you have the tidal effect or the stock drift. Just because in Copernicus there is also a dedicated product including these two components, so it could be useful to test or at least to know if there is a strong impact on your area.
Yeah, I know about that. And in that area, tide is not that strong, so we didn't include tide. Stock drift, it's as you said, it could be part of windage.
Yeah.
And what's that? At that time we did that. The HICOM was better in terms of interface, so it's an ease of access. And now we are using, as I said before, European project too, the Siemens. That's also quite nice.
It's not a question only about our project, just to understand the physical product and the physical content of the product you use, and how it is important for this type of application, for this type of length of forecast and everything like that.
Can you say that again? I probably...
Yeah, it was really to understand the importance of physical processes in your experiment. So if you know if it is really critical to have the tide or to have the windage or a precise stock drift parameterization or really a stock drift.
Yeah, in first case, the mean current was the most important thing, but the limitation in ocean current is it's a very coastal thing. And HICOM is okay for the general feature, but it was not able to produce river thing properly. So that was an issue. And probably that may be the reason we need a regional model in addition to big global model. And for other application, for the green tide, green tide and brown algae occurring yellow sea area, we need tide. So in that case, we combine tide from other side. So it's get data from here and there. So my strategy is using whatever available data to meet your purpose.
Okay, thank you again for this very interesting presentation. We will now move to the next presentation by Dr. Daisuke Matsuoka from JAMSTEC on the monitoring and quantification of plastic debris using remote sensing and AI.
Yes, can you hear me?
Yes, we can hear you and see you well.
Okay, thank you for kind introduction. I'm Daisuke Matsuoka from JAMSTEC. Today, I'm going to talk about monitoring and quantification plastic litters by using remote sensing and AI. And actually, this presentation doesn't contain the topics related to ocean prediction or forecast, but our monitoring and quantification method can output the amount of plastic litter in any fields, in beach or rivers or cities. And such information can be used for forecasting the pathway at the initial values of particle tracking. Okay, so as you know, plastic products are lightweight, clean, and convenient, and we can see many plastic products in the hospital, drugstore, grocery store, and supermarket. And the production of plastic products has increased exponentially since the 1950s to the present. And it's not a linear increase, but exponential increase. So during these 66 years, about 8.3 billion tons of plastic products has been produced. And this screenshot is the result of a Google image search for the keyword marine litter. Now we can see many sensitive images. For example, a sea turtle is caught in an abandoned fishing net. This is known as ghost fishing. On South Africa, large amount of plastic litters, such as colorful pet bottles, are accumulated on sandy beach. And this photo shows floating plastic litter on the sea surface, and here is inside the sea. So if plastic litter is properly managed or properly recycled, it's not a problem. But this map shows the percentage of mismanaged plastic litter in each country. In several countries, particularly in Southeast Asia, much plastic litter is not properly managed, and such mismanaged plastic litter could eventually enter the ocean. And such plastic litter is transported by ocean current in worldwide. Here is major ocean current in the East Asia, including Kuroshio current. And Kuroshio current transfer a large amount of plastic litter from Southeastern Asia countries to Japan. And this left figure shows the distribution of microplastic concentration observed by ship in the world ocean. Colored dot includes the observation data, and grayscaled area distribution estimated from simulations. Now we can see that many microplastics are concentrated inside the ocean currents in the Pacific Ocean. And that is known as Great Pacific Garbage Patch, GPGP. And why is the marine plastic issue so important? Because they have negative impacts on marine ecosystems and landscape protections, and they take much cost and much CO2 emissions for disposal and recycling. And that is not only the problem for each country, but worldwide problem. So in the G20 Osaka Summit in June 2019, the Osaka Blue Ocean Vision was produced by Japanese Prime Minister and shared by the leaders in each country. This vision aims to reduce additional plastic pollution by marine litter to zero by 2050 through a comprehensive approach, including remote sensing or machine learning or artificial intelligence. But at the G7 Ministers meeting on climate, energy, and the environment held at this year, it was agreed to move forward 10 years. That means zero by 2040. So how to reduce additional plastic pollution to zero? Of course, to reduce the plastic production, consumption, and disposal of plastic products, including the development of alternative materials, are very important. However, they are sometimes not realistic solutions because of the strong trade-off with economic growth. So the first step we can do is to understand the behavior of plastic litter and to monitor its pathway into the ocean, including the source and outflows to the ocean, as well as the amount of plastic litter in each field, such as land, rivers, coasts, and oceans. But one of the big problem is that there is no standard method for efficiently monitoring them. That is strongly related, that is strongly required. And over the past few years, we have been working to develop methodologies for monitoring and quantifying beach litter. Understanding beach plastic litter is really important for microplastic production, beach cleaning costs, and so on. Monitoring methods for beach litter have changed over time. In the past, many people used to walk along the beach and visually and manually count the amount of litter. But that is very hard work. So nowadays, automatic monitoring by remote sensing and quantification by AI have attracted much attention. And by analyzing images taken by drones using AI, it is possible to obtain information on the number of plastic litter, area coverage, and volume of plastic litter. So nowadays, several types of remote sensing devices are used for monitor plastic litter, such as satellite, drones, webcams, and cell phones. Satellite observation covers a large area but has low spatial resolution. Drone and webcam have high resolution but limited in the frequency, observation frequency, or the number of installed units. And there are many cell phones as well as there are populations. So now we are focusing on the utilization of cell phone. Okay, and we have also been developing AI, machine learning methodologies to quantify beach litter, which is applicable to the photos taken on the ground with cell phones. We firstly attempted to detect just two litter class, artificial litter and natural litter. Artificial litter, which is produced by human activities, including plastic litter, grasses, metals, and modified woods, and so on. And natural litter includes non-modified wood, seaweed, and so on. Not only these artificial litter and natural litters, our AI model can recognize other categories such as sky, sea, or sand beach, or background. To begin with training AI model, we need to prepare training dataset, which is a set of input images and corresponding output images. This training data is created by humans, experts, and it's very hard to create perfect training dataset. Some people are good at detailed work, others are not, and sometimes the results are different in the morning and in the evening. And creating the training dataset for 700 images takes lots of time and lots of money. But once training is completed, this AI can use to unknown data, which is not used in the training. And these types of image pattern recognition is called semantic segmentation, which is the pixel level classification of the images. And finally, we can get a perfect dataset to develop semantic segmentation model to detect beach litter. And now everyone can download the dataset and utilize it to develop their own AI models like this. And we also published data articles, which summarizes the detailed description of the dataset. Here, I want to show you the 3 examples of the image segmentation by using our AI model. From the top, from the left column, the input images, ground truth created by humans, and the output results by our AI models. In the first example, we can see white plastic box, and this is artificial litter. So the ground truth is red, artificial litter. And the output is also red. So that means artificial litter, this is correct result. And second and third example are very interesting. In the second example, we can see white buoy at the bottom left of the picture. Of course, this is artificial litter. But the person who made the ground truth was mistaken for the natural litter, this magenta color. But our AI can correctly detected this white buoy as an artificial litter. Similarly, in the third example, we can see plastic bottles at the center of the images, and the person who made ground truth was mistaken for natural litter, and our AI can correctly identify this object as artificial litter. So that means our AI is more accurate than human eye. And here are examples, but today I will skip this slide. So if you are interested in this detailed results, please follow our papers written by Hidaka, Dr. Hidaka. Okay, and our AI can be used to estimate the coverage area of beach litter like this. In this example, firstly, semantic segmentation is applied to the ground images. And next, semantic segmentation results are transformed to aerial images by using projective transformations like this. And finally, we can get the information about the coverage area of artificial and natural litter on the beach. In this case, about 160,000 square centimeters of artificial litter and 8,000 natural litter on the beach. And compared to the correct value from the drone images, as shown here, the estimated coverage from the ground images has just only 10% error. That is amazing results. So that means we can reduce much monitoring cost by using cell phone. And interestingly, this method can be applied to not only ground images, but also applied to take the images taken by the drone, like this. And this right example is application to time-lapse images taken by webcams. And now we can see the temporal change of the amount of artificial and natural litter. And this information and results are available online and is utilized to determine the timing of beach cleaning in the local government in Kagoshima, which is one of the prefecture in Japan. Okay, and this animation is the observation results by drone RTK mapped into digital surface models. By combining semantic segmentation and digital surface models, we can obtain three-dimensional information on beach litter, and we can estimate the volume of marine litter, not only the area coverage, but also the volumes of plastic litter, like this. Okay, and in addition, we have now created a new training dataset that allows quantification of plastic litter specified to plastic litter. With this dataset, every single object can be recognized in pixel levels like this, to estimate the number of plastic litter, area coverage, and also volumes. And this is our new dataset named Beach Plastic Litter Dataset, for short, BEPLI dataset. And this kind of dataset includes the information of PET bottles, fishing gears, food trays, and plastic bags, and so on, like this. Okay, and you can download it. You can download this dataset from the data repository, and the dataset annotated with over 100,000 plastic objects in about 4,000 images from 167 locations on the coast of Japan. But now we are preparing 13 categories of major plastic litter dataset, including PET bottles, plastic bags, fishing gears, and so on. So please stay tuned for the future announcement. Okay, this is the final slide. Currently, we are attempting to integrate several different monitoring to understand spatial and temporal distribution of plastic litter from the land to the ocean through the rivers. That means to quantify the abundance of plastic litter in each location and to identify the source and pathway.
1 minute, please. Sorry.
Okay.
1 minute, please.
Yeah. Okay. That's it. Thank you.
Sorry.
Oh,
Thank
this is
you
the
very
final
much.
slide. It's okay.
Thank you very much. It was really outstanding talk, very interesting. Are there any questions in the room? Or yes, Jan? Maybe we can check online questions too.
Yes, thank you for your presentation. Just one question, do you think it will be feasible soon to cover the full coastline of Japan, for example, with this type of methodology and with the observation, the citizen observation we already have, and with this type of artificial intelligence method to map everything? Is it
thank you
feasible at short term or short term perspective?
Oh, thank you for the comment. So where are you from? You are from India or?
We are from
now, yeah, now we are collaborating with other countries, research institute or universities. So now we are attempting to apply our methods to other locations in the world, especially India or other countries.
But
you
said,
feasibility studies.
You said you were in the process of implementing this for society, so I guess.
Society, yes.
Yeah, to be able to use citizen science information, such as photos taken by people, and sending them to you on an application. Is that it? Yes.
We have a couple of model locations, model cities. For example, Yokosuka cities in Japan, and yes, and also today I skipped the detailed description, but in Japan we have a small cell phone application named Pirica. That is the SNS applications for taking pictures of the beach or cities plastic litters, and we can use these photos uploading by citizens. That is one of the example of citizen science.
Okay, thank you very much again. And so we will now move to the next session on ocean literacy and capacity development. And we will start with a talk by Dr. Adi Rameyo from BRIN, Indonesia. Connecting ocean forecasting with traditional knowledge towards social ecological resilience. Are you here, Dr. Adi? Okay.
Sorry.
Hello. The floor is yours.
Hello. Good morning, everyone. My name is Adi.
Can you put your slides in presentation mode, please?
Oh, sorry. Let me.
No problem.
It's okay now?
Yes. Yes. Go on, please.
Thank you. Thanks also for inviting me. And I would like to also apologize for not being able to join in person in San Sebastian. Also for not being able to follow all full agenda during 3 days. So my title today is actually very much inspired and based on the one mission in the prediction for ocean prediction DCC, which is using ocean forecasting as a focal point to foster intercultural dialogue. The important thing is intercultural dialogue toward the ocean we want, and it being used also can be used also as a community development and capacity building strategy in the framework of the future ocean literacy. So I will start why I use this the title. If we talk about the community development and capacity building with intercultural dialogue approach, we need, of course, we need to know about what is their own knowledge in terms of traditional or local knowledge. It is very important, particularly for the country, archipelagic state like Indonesia, since we have many islands and with different people and culture, as well as their knowledge. So that's why this is very important to start if we are going to make a ocean literate people, particularly in a community, to start with their own knowledge. So this is why this. Before we further talking about the traditional and local knowledge, I would like to just a little bit mention about the Ocean Decade of Science. In fact, Ocean Decade of Science is actually a big effort how to transform ocean science solutions for SDGs. And second thing is actually how to make how to connect people with their ocean. So, but what is the issue actually? You can see that the Ocean Decade Science Action actually is an effort how to transform from our ocean situation right now, which very much a lot of destructive activities, overexploited, and also pollution, become our ocean that we want for our future. The focus is actually a behavior change, how to make people change their behavior to become more positive to the ocean. So actually, ocean literacy is how to build ocean literate people at all levels, both at policy and action level, to ensure that our ocean is sustainable and at large. So basically, ocean literacy is dealing with people engagement and community participatory. So the benefit of the ocean literacy actually is in this region is one is how to make a sustainable ocean management, and the second is how to build community resilience. If we talk about the community resilience, we will deal with not only with the people, but also with their knowledge. So in most of islands and archipelagic state, the population, the people, the local people, they have already their own knowledge. In fact, the coastal community is they are the most knowledgeable of their with their environment and also their resources, but they also the most vulnerable from a change, for example, like climate change. So this is my favorite slide actually, how the community, they have a knowledge connected with the ocean for many years. For example, here in Indonesia, we have some traditional knowledge how to manage fish resources, that now in a modern science known as ecosystem approach for fisheries management. Basically, it's open closed system by the people. So we think that the EAFM, or ecosystem approach for fisheries management, is actually based on our some best practice of the people traditional knowledge. Another example is in the integrated coastal management. For many years, maybe hundred or thousand years, we already have our knowledge. They already have their knowledge how to manage how to make their coastal zone that with the traditional ways. So furthermore, I think it's not only in Indonesia, but in case Indonesia, you can find almost all in over area in Indonesia the community-based management manage marine and coastal area with their own traditional local knowledge. Not only that, we also identified that we collected a lot of traditional or hazard knowledge by the local community as not only ecological knowledge, but also hazard, disaster-related knowledge. As you know that Indonesia Nusantara is archipelagic, located in the Ring of Fire. We have a diverse resources, a lot of resources, but we also affected by a lot of many natural disaster. So we realize also that most of people, they already have their own knowledge how to facing with disaster. One example is SMONG, which save people in small island Simalu, the most outer part of the in Indian Ocean, from the great tsunami disaster in 2005. So so this is the base why we need to build a community resilience based on a social ecological system that they have. Talking about the traditional knowledge and social ecological system, now the demanding of how to incorporate this their knowledge and also the social ecological system in a framework not only local but also national and global at the global level, like for example in a UNFCCC forum that now they establish about the local community and indigenous people framework, as well as SDGs. SDGs also establish local community and indigenous platform, and in particular World Ocean Assessment in third cycle, the traditional knowledge is very important and become the another output of the World Ocean Assessment in terms of capacity building, and the social ecological system as well. There is a special section with a big chapter comprising a 10 chapter for sustainable inclusive ocean economic and also ocean health, which also pay attention on indigenous and traditional knowledge. This I would like to share some experience in how to we try to build some showcase based on local community experience. One is about the eco village. This is experience based on the one island in northern part of Jakarta, which used to be affected by waste, not only for from the island, but also from the 13 river from Bay of Jakarta. But after 5 to 7 years action, they move from zero waste island, from waste island to zero waste island. And now this initiative is adopted by a big company in Indonesia to become a model to make an eco village around Indonesia. And another new initiative come from Ministry of Marine Affairs and Fisheries. We try to improve livelihood with a smart fisheries village, which is based on aquaculture, ecotourism, and salt farming. And another also they produce another program called Advanced Fisher Village in for capture fisheries with basically the aim is how to make a 3D benefit of development, not only economy but also social and ecology. And another initiative is Indonesia now try to establish some disaster resilient village. This is basically is using a multi-hazard approach, but the important thing is also based on the science, blended knowledge, combining between science, modern science, and local traditional knowledge or wisdom. So the last part of my presentation is how to incorporate ocean forecasting into ocean literacy for community development. So we work with this definition. Actually, ocean literacy is the effort on how to make an ocean literate person. Ocean literacy here defining as the understanding of the ocean's influence on you and also your influence on the ocean. So an ocean literate person is actually the person that understands the essential principle and function about the ocean, and they can communicate about the ocean in a meaningful way and able to make informed, responsible decisions into the ocean and its resources. So based on that, since ocean forecasting is a part of the understanding of the ocean, and then the ocean literate people also need to know how to gather information, prediction about the ocean, and how to distinguish credible and non-credible resources for the subject. And the important thing is how to use and communicate about the ocean variability, ocean dynamic in a meaningful way with their own language. This is one approach we suggest based on our experience is we need interface, in fact, how to bring the ocean forecasting product to the people. So this is there is an initiative in 2015 among BMKG, Meteorological Services, and Ministry of Marine Affairs and Fisheries, and also Institute of Technology in Bandung, to initiate Ocean Clips. This initiative is inspired by the WMO program CLIPS, Climate Information and Prediction Services. And after many years, now this initiative now collaborating with a private company, how to providing information, particularly on for the fishers of the fishing zone, sea state, weather condition, sea navigation, and fish price, and etc. And now there are applications based on Android, which can make a fisher easily to know the information and to analyze their resources locally. So another suggestion is for the how to bring ocean forecasting into ocean literacy is building a showcase. The showcase can be based on the village that I mentioned in the previous slide. For this thing, Indonesia can be will be ready for your partner to build a showcase. And also the third suggestion is how to make engaging community knowledge into the decade action with three strategic, working with local, more with a local community, and also use a cultural approach, means incorporate their culture and language, and working with the youth, proactive with the youth. And this is also, I would like to suggest the last slide, collaboration with other regional initiative like Blue Citizen Initiative under APEC, traditional knowledge working group under IOC Westpac, and also Genocean. I think this is my all sharing. Thank you very much. Gracias. Terima kasih.
Terima kasih. There's one question from Enrique.
Yes, please.
First of all, congratulations for excellent presentation and very, very interesting initiatives. I hope you can hear me okay. Do you hear me well?
Yes, yes, yes.
Good. I want to, you mentioned it very, very briefly, one initiative about traditional knowledge and tsunami smoke or something like that. It was called. I would like to learn more about that. Why this cultural traditional knowledge save lives? How was that story?
In this particular island, there is like a saying that this say like poetry. They deliver from generation to generation. What I want to say is this say is actually is how what we do if there is some kinds of condition. This special condition is very, I think it's very remarkable for the people. So this is actually the early warning from tsunami of the tsunami. So if you see this kind of condition, please go to the mountain. This is the saying that transfer from generation to generation. I can send you some readings if you like.
Yes,
this kind of cultural in detail.
Yeah, I will really appreciate to know the details of that. This is very interesting, and I would like also to ask you if you can give us some specific examples on how you were mentioning that you were mixing science with traditional culture in your ocean literacy, in your capacity development of the population. If you can give us some specific success story on how you did that mixing of science with traditional culture, that will be great.
Yeah, there is one story from Sulawesi Island, what we call it, Celebes Island. They actually have their own knowledge how to predict, how to forecast where is the fish is based on wind and also tide. This is local knowledge and delivered from generation to generation. And now, some scientists from our research agency try.
Sorry, we lost you. We are investigating this at the moment. Maybe you can hear us online. This is just an interruption. Sorry for this. Is there somebody online? So we will soon switch to an interactive session. So do not disconnect, please. Stay with us. We will come back very soon. And so Enrique will. Okay, are you back? No. Yes. Maybe we can. Yes, maybe. Okay. So we can. Sorry for this. This interruption due to technical problems. And now we are back online.
Hi.
Hi.
Sorry, well, we have a problem with the electricity in my house. So I'm sorry about that.
Okay, no problem. We just said that we would very much like to know better about your examples, and you can send them to Enrique and to Swadhin, because it's going to be, you can send to Swadhin and Enrique, to both of them. Yeah. And so and there is another, is there another question?
Okay.
There's an online question, okay. For this session, I guess. Okay, so this is a question on what is your proposed remote sensing proxy variable for forecasting waste dissipation into the environment by aquaculture activities in Indonesia? So I'm not sure this is a question for you, Young-Gyu or Adi, but it's not so clear. Adi talks about such matters. I'm not sure. So maybe we can. But Adi was not really talking about that. It was more related to, for instance, I think Young-Gyu Park's presentation, but it was not about Indonesia. It was, for instance, if you had an idea of a proxy variable from satellite data that you could use to monitor the waste from aquaculture farms. Do you have any clue on that?
So I don't know the exact situation in Indonesia, but in our case, we monitor, what's that, buoy, styrofoam buoy used in aquaculture. That's a main source of microplastic. So you may be able to do that. So what we did was, from satellite images, we counted actual number of aqua farms and got number for, what's that? Got an estimate for waste on styrofoam buoy. That's what we did.
Okay, thank you very much. Any other question? Or we can follow the session. So we'll go directly to the interactive Slido session. And so you can, I will leave the floor to Enrique for this. Thank you, Enrique.
Okay, thank you, Marie. So we will move now. We will try to have a little bit of fun with this interactive session. Please connect to the Slido. You see the code there, and the number is a little bit difficult to read for the Slido session, but it's on the chat. So please connect to slido.com and use the code number that it's on the Slido. And the idea here is that we are going to ask you some key questions about issues related with ocean forecasting in your region. And we are going to try to comment online your replies. It's like a little game, and we are doing this on the different regions. We have been doing this on other regional team meetings. It has been quite successful in other regions. So I hope that you can help us going into slido.com, introducing the code, and start replying these questions. Please, when you reply, don't use more than 2 words. It's just a 2 words sentence, because if you use more than 2 words, it gets very confusing then the analysis. So we see a first question here. Which are the main applications that ocean forecasting is having today on the region? So pollution monitoring fits perfectly what we have seen up to now. In this morning, we have seen the large problem with plastic litter, how this is contaminating beaches, and how this can be controlled with citizen science, thanks to artificial intelligence. It was a great presentation today, showing this application of using artificial intelligence. Please come into the Slido and contribute additional to the questions, so we can have an idea on what is your view on how ocean forecasting is being applied on your region. More replies are coming. So ocean current prediction, which is obviously linked with the previous one. You need this current prediction, warning systems. This is very important in the region. I can understand from all the presentation on previous days. We have been hearing our colleagues in China talking about warning system related to waves, related to construction of infrastructures. Tsunami warning system is obviously very important in the region. Fish stocks. Obviously, fishing is part of the economy and also part of the culture in the region. So knowing about fish stocks is very important. Pollution is same thing like pollution monitoring or very linked. Sea surface temperature, that should be important also for biologic ecosystem applications, also linked with the fish stocks. Again, pollution pops up as a very important issue. I think this is relevant because in other regions, pollution was present, but maybe not so much like here. So this tells us a lot about the importance of what we are dealing with. Traditional knowledge linked very much with the presentation, with the wonderful presentation you just have had. Search and rescue linked with ocean current forecasting, of course. Surface ocean current, the same thing. So it's great. We are having many answers, but there is a very, very clear this time. I have to say that in other regions, it was more diverse, but here there is a very clear, and it's getting larger and larger, very clear importance and very clear use of pollution debris, pollution, plastic pollution. Okay, we have now a new one, ship routing, very important. But clearly pollution is where ocean forecasting is having an impact in the region, again, following our audience. Also, other things like warning systems are important and are coinciding with the analysis done in other areas. So I think we can move, Vincent, if you want. Please keep on dropping your replies on the 5 questions we are going to show, because even if we are not seeing that, that will be stored and we will collect all this information on a final report showing all the work clouds for all the different regions, and it will be nice to see the difference from one region and another. So yes, it's great. I see a lot of replies popping up now. Thank you very much for your participation. So you can continue, as I said, dropping as many answers as you want. 2 words, please, in the 5 questions. So limit the length of each answer to 2 words, but you can drop as many as you feel are needed. So our second question for today is, which are the main gaps for ocean forecasting today in the region? So this is your turn to tell us, where do you feel we have to focus our effort as scientists trying to deliver better forecasting? So marine heat waves is a first answer. I mean, this is very related with the previous reply on the previous question about SST. Green tides, I guess this is quite logical because we have seen on the presentations of these days that our scientists are not that sure about our ability to deal with green ocean as we are able to deal with blue ocean. So it's not strange that green tides are on this list. Uncertainty quantification, we have seen the presentation by Marie yesterday on how Copernicus is dealing with this, and I think this can lead, this can be an example on how we deal that at OceanPrediction DCC. Mesoscale eddies, I like this one because I fully agree with that one. This is related with our data assimilation system. This is related with our ability to have more and more observation. Ocean observation data, that one is obviously linked with mesoscale eddies because we need that. Climate change, marine heat waves and climate change. So marine heat waves seems to be a concern about how we are doing. Since we are not, for the audience, we are not maybe being able to deliver the right information related to marine heat waves. Air-sea interaction, that's a very transversal comment in the sense that is related with difficult things such as coupling, important things such as coupling, exchange and intercomparison. This is so nice because this is what we are about here at OceanPrediction DCC. And accuracy is related with many of the things you are mentioning, such as the mesoscale eddies, uncertainty quantification. Ecosystem model is linked with the green ocean and the green tides that we have seen. So it's very much about the way we are able to, on one hand, I see like some families here, we have the heat wave as a main concern, and then another family related very much with the accuracy, where we can put the eddies, we can put the uncertainty quantification, we can put also the ensemble. And then we have also a third family, which is the biogeochemical. We can see the green tides, the ecosystem modeling there. So that is for me the main three families that I can see in this cloud. I can see all things related to accuracy, all things related to eddies, on how well we develop this, on uncertainty ensembles, then the marine heat waves, and finally, the green ocean. Okay, estuary area, I think that pop up suddenly very strongly. So I think that could be also linked with high resolution in general, probably. Not only estuary, I guess, but high resolution complex systems and ecosystem models is having another reply. So this goes for again for the green. Let's go to the next question, and please keep on delivering your answers on this slide. Okay, we wait a little bit. Vincent is asking me to wait a little bit more. Mangrove monitoring, again related to the, okay, this is very interesting because it's related with the coastal interaction, and it's also related with the green ocean. So seems like we have in the ecosystem modeling in the coastal area frontier that we have to advance and that we must resolve. So let's go to the next one. This is for you to help us to, after what you have heard, what is, I hope that if you've been during the 3 days, you have now a more precise idea of what we are trying to do at OceanPrediction DCC. So this is for you to help us where we should focus to improve the situation in ocean forecasting in the region. Remember when you reply that we are not at OceanPrediction DCC, let's say a development body, but we are a coordination body, and we are here to promote joint approaches towards ocean forecasting, but we don't have the ability or the capability to do ourselves the coding, to do ourselves the systems. So we are here to inspire dedicated solutions. So marine heat wave means that we should put effort on that. I think this is interesting, maybe for our plans related with indicators. So being marine heat waves such a predominant worry here, I think we have to tune our indicators, our ideas related with indicators that we were explaining these days around this concept of the marine heat waves. Technical interoperability, this is exactly where we, this is very good because this is exactly where we are focusing our effort. Surface circulation is obvious in our case, I think. And outreach is related also with the capacity development plans that we are planning to implement. So not a strange, marine heat wave is again very, very popular in where we should focus. Technical interoperability, so plankton capacity building. This is very nice because it really fits on what we are trying to do. Pollution, again, in this case, accidental pollution, different kind of pollution than the ones that we have been discussing previously. And it's also very linked with the activities we can have. Common best practices, this is, I think, a good one because, yeah, it really fits on the activities that we have planned to do. Heat waves are, again, popping up. Now, we have several entries, again, with heat waves. I don't know, maybe somebody on the audience want to comment if you feel surprised about how important heat waves are, or you feel that this is something expected. I don't know if you want to comment on that. Okay. Fisheries, interoperability. So let's try to, again, to summarize a little bit what we have here. So we have like very technical things such as assimilation, technology, accidental pollution, interoperability. So that's a family of things which is, I understand, promote these technical developments. Then we have, of course, marine heat waves as one important issue you want us to work in. And then we have other family of things related to cooperation. We can see here blue citizenship. We can see unified standards. We can see best practices, capacity building, technical interoperability. So I see like these are the three families. Let's say the technical part, promote technical things such satellite data simulation, then marine heat waves as a family by itself, and then all the things related to capacity building, to creating a community, starting by blue citizenship, outreach, best practices, technical interoperability. All these are things related with the community building. So I can see clearly these three families. So thank you very much for all these answers. I think this is been very interesting. So we can move to next question. What kind of capacity development and or ocean literacy activities do you believe are needed in the region? So this is your opportunity to try to steer our capacity development activities in the future, to try to help us aligning what we should do in both capacity development and ocean literacy for the service at your region. So let's see what you feel as needed there. And it will be, again, I insist, very nice to double check, to cross check what are you suggesting in this region with what has been suggested in different regions, to understand if there are, for example, in capacity development, different ideas that are required at different regions. That will be very interesting to understand if we have to develop our capacity development activities, let's say in a common form for all regions, or if we have to instead fine-tune the capacity development activities in depending on the region, depending on the regional team. So it's important to understand these local differences. So data monitoring, local data monitoring. This is very nice to learn that you believe that you need some capacity development on how to deal with this data. Ocean management, modeling in general, okay, so that means a complete and integrated approach towards forecasting and modeling in general. Downscaling, high resolution modeling. So this is how to transform the existing global and regional models into higher information, basically how to downscale. I understand it like this. Share data and tools, how to be interoperable. Notable notebook and tutor, I don't get that one. And tutorials. Okay. So that's a very interesting thing because it tells us about the way of doing the things. So it tells us that practical things in capacity development are welcome. Something like Jupyter notebooks, I understand, could be an interesting approach towards completing that. Summer schools, okay. Ocean management, local resolution. So summer school is a good alternative. We are asking also through some surveys on capacity development, what is the best way to approach people. If maybe you can also tell us if you prefer online events or you prefer in-person events like summer schools. Both approaches have advantages and disadvantages. Obviously, with the online events, you can reach to more people. Summer schools are a way to get more contacts and are a way to get more customized capacity development. Shared data and tools, I guess that means that how to use these data and tools that could be available for the community. Assisted decision making, that is related. That's a very important one because it should be. It's linked with the previous presentation. This explains how to put together all of the science and the traditional knowledge into the decision making. Children education is very much related with ocean literacy. And I guess it's very important in Asia, having a very healthy population pyramid, not like in Spain. So children are the future and very important. Test cases, teaching by test cases is also something that has been repeated in many of the surveys. So use examples for the teaching, especially for the, this is linked with the decision-making and the downstream part of the value chain. Hackathon also as a methodology to learn. So again, families are somehow popping up. Trainers is very nice because that's that has a multiplicative effect. This is very smart. So I can see here like very clear family with suggestions on how to do the capacity development. We have several ideas like hackathons, trainers, seminars and workshops, summer schools. So all these are how to do this, how to do the capacity development. Then we have other families on what to teach, where to focus. I can find here best practices, ocean management, brief for policy, how to utilize forecast products. So basically, these are the two main families of inputs that we are having here, which are very useful. In this case, we don't have a big answer, something that is popping on top of everything, maybe because we don't have marine heat waves on this category. But I can see a very dispersed cloud of ideas, of very, very nice ideas. So we go now for our last question of the, well, I think it's the last one, isn't it, Percent? Yes. Do you think, that's a good one. I'm looking forward to your replies in this one. Do you think observations from the region, if available, are sufficient to constrain the ocean models and produce accurate forecasts? If not, what kind of observations are we missing? So this is for you to tell us, what do you think about the observing system in your region? Do you think it's enough for the purposes that we have, especially those related with ocean forecasting? And if you think that your observation system is not good enough, please help us to find out what do you think is missing. So do you think there's one person that believes that the observations are good enough? Other person believes that we need more ocean currents. Okay, very optimistic view with several. Yes, surface currents are missing here clearly. Long-term systematic observation. That's a very good one, because this is the most difficult thing to observe in the ocean. Is the most difficult thing is to keep long-term systematic observations. Biodiversity, this is for sure something that is probably missing, because it's missing everywhere. The green ocean is not well and systematically observed. Deep ocean, that's a good one also, because it's true that generally deep ocean is not very well observed. Surface currents are very important, apparently, because I guess this is a region with many parts of the region. There are very strong surface currents, so it's not strange that this is popping up as a source of. We have seen how important, for example, today surface currents are for marine litter dispersion. So it's not strange that this is popping up. Frequent satellite passes, that means more satellites. It's the only way. And more satellites means either new technologies for satellites or much more money put into satellites, because with the technologies we have today, each satellite is very, very expensive. So either we go to new technologies that allow us to have smaller and cheaper satellites, or that will be really expensive and really difficult to have. Same with surface currents, to be honest, because most of the technologies able to provide us surface currents are quite expensive, such as HF radar or moorings. River nutrients, that's also, I have to say, another traditional input on the different regions. The river data is not, the rivers are not usually well measured, especially in the mouths of the rivers. We are lacking information in the mouths of the river that is helping us to understand the connection between the rivers and the ocean. And very particularly, you are saying river nutrients. So we are here again connecting with the green ocean. So I can see, like here, 3 families of replies. One family saying that yes, we have enough observations. Another family saying that currents are missing. And finally, a third family telling us that green ocean is missing. So we don't have nutrients, we don't have nutrients and productivity, we don't have ecosystem and biodiversity. Finally, there's maybe another set of replies related to long-term observation and operational observation, telling us that, okay, maybe there are some campaigns, some punctual data, but we need long-term systematic observations, or as another person is suggesting, named Operational Observations. So Vincent, I don't know if there's any more question flowing. If not, thank you very much for this. I think it was very interesting. I can see differences with other regions. For example, it was very interesting to find out the stress on marine heat waves and the stress on green ocean that you have had during the whole exercise. I think it was fun. Thank you for everything. And we will try to put together these answers together with the rest of the regions, trying to make a map and trying to find out differences depending on the region, since we are doing the same exercises in all the regions. So please make sure you are back for our last session, starting at 10:30, and it will be about the wrap up first. Swadhin will, the chair of the regional team, will give a wrap-up presentation of what we have been discussing and the findings of these days. And finally, we will have, I think you will find it very interesting, an event with the port, where the port will show us their applications, their interests, and their connections with ocean forecasting, and why they are promoting this kind of initiatives. So thank you very much, and see you back at 10:30. Bye-bye. So welcome everybody back. Thank you for being here. And it is now my pleasure to introduce again to Swadhin, which is the chair of our regional team. And he has the very difficult challenge of summarizing in this session what we have been discussing today. So instead of having the presentation, we will focus only on the presentation of the chair. Swadhin will do for us the summary of and the conclusions of these intense and very nice days of work. So Swadhin, please, the floor is yours.
Thank you, Enrique. It has been, as you said, very nice 3 days for us, and in a very nice place. We can see the nice place, but we have to be inside to work. But it was really nice and very interesting to interact with online participants as well as on-site participants. We had intensive discussions on how to proceed and what we should do and what need to be done, what are the gaps, what we can do, and what we should do in next 1 or 2 years. To start with, I will show you the sessions, the plan of the sessions, very nicely prepared by Enrique and team. So we had 3 general sessions with presentations on ocean observations, then ocean forecasting and downstream users. And then today we heard about the marine leaders and capacity developments. And then we had one interactive session today where the marine heat wave came up clearly as one of the key topic we need to address in this regional team. And then we had 2 very nice brainstorming sessions with the steering team members of this regional team. And then we had 1 brainstorming session with the chairs of all regional teams. And several topics came up very clearly in those meetings, and it was very constructive for us to pick up some of the points to proceed further. And then we are wrapping up now. I guess we had about 700 plus registered participants for this meeting. And then probably we had about, Vincent will later tell us exact numbers. Probably had about 300 unique participants, online and on-site participants for this 3 days meetings. And to start with the session 1, we had on Wednesday, and I think Enrique did a great job to introduce and update us about the activities we have been doing for this team, and in general for all the regional teams. What is Ocean Prediction DCC, and he updated on technical component and the community building component. And then also discuss a little bit about the capacity development and ocean literacy. The idea was like in 2023, this is the implementation year, so we'll have the homepage ready and the tools and design and all activities for capacity building will be ready, so that in 2024 we can launch on some of those activities and start working on the topics we have decided. And to start with, Enrique gave us these 3 possible architectures for going forward. The architecture A is kind of no digital twin in it. The existing one with kind of Copernicus kind of activity where we have different components and we bring the data to one platform and then share with the users, researchers, and stakeholders. It also has a interoperability component But the easier one will be having a digital twin as an intermediate function or a complete function. Like plan B, architecture B is like having the interoperability with the digital twin as an intermediate function. And then we have the architecture C, where it is fully digital twin and everything goes in and then the results come out. And it's easy to interoperate and as well as standardize the data. Then we discussed, I'll come later to that. So then we discussed how we proceed. We have these three architectures. And then the idea was like, start with the first one and then go to the second one. And towards the end, maybe we have the third one. And all three are important. It's not necessary that one or others. It's that we thought that all three are important and we'll keep all three for various purposes. And then he introduced about the community building, the other side. The one side is the architecture, which is designed by the architecture group. The other side is the community, including researchers. So researcher might think, okay, this architecture is good for me or not good for me. So there is some interactions and we discussed a lot and most team members agreed. I think the three architecture which Enrique suggested are good enough for us and we can work on them. And the other side is like developing the community. Not only we do research and the development, but also build the community, including stakeholders. So that's why he suggested having the homepage. Homepage will be ready soon. And then we'll have the atlas of all activities, all teams, who is doing what and what is available, so that in one platform we can see everything. At the moment, it is not so easy to summarize how many models we have, who is doing what. If somebody wants to use, for example, a particular model in a particular region, he should be easily find out from the map once the atlas is ready. Then we will have the forum for discussions, not only the technical issues, for example, how to assimilate X, Y, Z data, or like what we should do for the marine heat wave in a particular region. But also it could be like stakeholders asking something, okay, I need this information, from where I should get it. Then somebody can come up, some researcher, and give those answers. So the forum also is a good way to develop the community and keep engaged with the community, so that the regional team is visible always. Then you have the news. He suggested we have regular news activities, like once in a month or at least once in 2 months, exchange some information, some news, and update that among the team members through the secretariat. And then resources, we thought maybe at this moment we use the shared resources. Each team member or like steering teams, they have their own resources. So at the moment we can use that, but he thought maybe there is a possibility we'll get some funding later, which will be helpful. At this moment, we don't know how the funding will be and for what purpose it will be. And then he also gave the results of the 2 surveys we had in the previous meetings. One thing came out is that the local coastal use is the most possible ways that expert felt, okay, these are the areas like coastal ports and those kind of things where we can use our expertise and the available products for the stakeholders. And the stakeholders also said they are satisfied with those local products. Unlike our expectations, expert felt maybe we are not accurate yet, but the users thought maybe they have some products which they can use. So there is some match there, and it's a good news for us to proceed further and improve our products. Then for improving the products, he thought of this kind of capacity development, and one of the things came out of the of the discussions, and his presentation was the eTubes guide. I think that is going well, and if you have a good several kind of eTubes guide, I think one thing we discussed is tsunami eTube guide, which should be one thing we should add it to the topics to be done. And those eTubes guide can be then endorsed by IOC or other agencies, which can become one of our key achievements in this project. And then we had presentations. We invited 2 other groups. Okay, we are doing this, but there are other programs who are probably doing something which is useful for us that might be complementary to each other. And we can share information which will be useful to them, and they can share that information which will be useful to us. So we invited 2 groups. One is GUS and near GUS. The other one is UNEP COBC. And Dr. Rameyo Pang from NMEFC. So he presented about the near GUS. And prominently he talked about the observations being done in partnership with China, Japan, Korea, and Russia. So there are some specific lines he showed which have been used for observation by this group. And he also talked about the CSK2, which was later fully covered by Dr. Ando from JAMSTEC. This is a new program, Ocean Decade program, supported by IOC Westpac. And it's about the Kuroshio system, including biogeochemical processes. The other topic was COB-C, Seas of East Asia, one of the 18 regional seas to cover several topics. And then there also Mohesh talked about the marine litter ecosystem and the James Ocean Program. And thanks to Jan for summarizing this. Jan summarized this very nicely. And then we had several presentations on the observation activities being done in this region. Basically, we had discussion about the satellite observations and also the in situ observations from specific lines done for CSK2 or some kind of JMA, and also KIOST lines, which Dr. Park presented later. Dr. Wan from NMEFC, she talked about the different kind of satellite with 3 major areas for observations, like ocean disaster, marine environment, and the marine resources, including sea level variability. So also she presented something about the Antarctic and the Arctic, sea ice and other activities. Then Anderson presented about the Argo, the TPOS, CSK2, and JMS lines. So these are some kind of specific observations, not in general observation. General observation, of course, we have the Argo floats, the satellites, but Dr. Ando and Dr. Park later, also Dr. Agus from Indonesia, they talked some specific observations which were useful to understand some of the processes. Like Agus was talking about the mixing in Indonesian seas, and Young-Gyu was talking about the coastal processes and also Bering Sea observations and the processes they observed there. And then we had the yesterday we had the presentation on ocean forecasting and downstream services. So 4 models came up during those presentations: MACOM from NMEFC, Jacob from JAMSTEC, and the FIOCOM from FIO, and the BMKG OFS, Ocean Forecast System, from BMKG Indonesia. So those are the 4 major models came up during the presentations. I think besides that, we also heard today about the HICOM from Dr. Park. But basically, I think these are the models we have been we are having in our region, which I think we should discuss more, how to pull them for the results and also to develop the digital twin kind of things. One thing I wanted to hear, which I didn't hear, I wanted to ask, but we didn't have much time, is the use of AI machine learning. AI and machine learning. So I think none of the presenters exclusively discussed about the use of AI and machine learning in their models, but I'm sure the AI and machine learning already being used in like data assimilation or kind of understanding biases or preparing the downscaling services from the model outputs. So that I think we need more discussion. Probably in the next meeting, we'll keep one session on AI machine learning, how it is being used at the moment. And yesterday's session started with very interesting talk by Mr. Abote, who presented the ancient shipbuilding, which they are now kind of replicating now here. We also had a demonstration yesterday. And then he also showed how the explorer in 16th century tried to reach Asia through the Pacific Ocean. Before that, people didn't know about the routes to Pacific Ocean, and he also said how it was challenging for them to come to the Asia and also going back. So eventually, they discovered, I think, the ocean currents and how to use them to come to Asia and go back. And then Dr. Fuji presented about the CNOVs. I think he focused more on the OSCs and how OSCs are being used in that project. Not only the OSCs with the ocean, also he talked about the S2S, including the ocean atmosphere coupled models, and how the OSCs are being helpful for them to recognize the role of observations in the predictions. Very nice. Please bear with us. We had some technical issue. Will come up in 1 minute. Okay, it's done. So then we had these three presentations about the model like Macom, Jacob, and also the FIO. Okay, so sorry for the interruption. What I was talking about the forecast systems, which we discussed yesterday. Dr. Zhang discussed about the NMEFC's forecast system, MACOM, and he talked about like 1/12 degree to 1/24 degrees, good skills up to 5 days to I think 10 days. And then he also talked about the very high resolution downscaling to 20 meters, which was used for swimming and sailing for the South Asian Games. And then he said that NCEP results, reanalysis results, and forecasts are downscaled using WARP for those kind of high resolution simulations. And also he talked about the Arctic Ocean ice being simulated and predicted by that model. Miyazawa-san, Dr. Miyazawa from JAMSTEC discussed more about the marine heat waves. We had a persistent marine heat waves around Hokkaido, Japan, and that lasted for a long time and affecting the marine ecosystem and especially fishery in that region. So he focused more on that and the prediction of that. And then Dr. Bin Zhao from FIO, he talked about their model and how the ocean mixing, by improving ocean mixing through the wave and tide models, by coupling wave and tide models in their model, he showed better results. And he also talked about variety of applications for coral reef, oil spill, ship accidents. And then he talked about how they're using this system for capacity development by providing that kind of model to Thailand and some other countries, and also having training programs in their center. Then we had several, like 4 presentations about the ocean services, downstream services, led by Dr. Dakui Wang from NMEFC. And he said how they have the national center for this kind of operational products and also regional centers for the operational products. And NMEFC is the national center. And he showed how the services are being provided for various users, from oil spill to Arctic and Antarctic research teams. And also they are providing the capacity development through regional training and those activities. Then Dr. Andri from BMKG also talked about their model and how they're providing those services to the stakeholders. They're using wave model and WRF and ROMS to develop their ocean forecast. And then he showed some validation of SST predictions and current predictions, and how that information is being used for fishing ground predictions and early warning systems. And then we had 2 presentations from Mary and also from Stefania. And basically, Mary covered how the system is used for understanding biases and understanding the errors. Please correct me if I'm wrong. And how they're developing the Copernicus system for more interactive and improvement in understanding the uncertainties and also errors in the forecast. And then Stefani said about the use of those products in different applications, how the data from upstream is given to downstream users, and how they're engaging the downstream users through improvement in the products and services. Then today we had 3 presentations on marine litters, ocean literacy, and capacity development. Dr. Young-Gyu Park from KIOST, South Korea, talked about the marine litters, especially focusing on one event. We had a volcanic eruption in Pacific, and the pumice stones floated towards Japan and Korea. It was a big menace at that time, and people wanted to know, especially port authorities wanted to know in Japan when they are expecting those stones. And in JAMSTEC, we did that quickly, and those informations were provided to the port authorities for cleaning and mitigating problems. But many ports had problem for several weeks and even up to 1 or 2 months. And Dr. Park presented some of those particle tracking using the HICOM model outputs. And as he mentioned, that satellite observations are useful for validating as well as initiating the pumice stone into the tracking systems. Then Dr. Matsuoka presented about the use of sophisticated methods to understand beach litters, monitoring beach litters, especially the plastics in beaches and coastal regions. So he presented how the AI techniques can be used together with satellite information, the satellite, the drone cameras, and also our smartphone cameras for detecting beach litters and monitoring them and quantifying them. Then Dr. Rameyo, we heard just before this session about the excellent work they're doing for ocean literacy and capacity development. He talked about how to blend the traditional wisdom with the scientific wisdom so that it can be applied effectively, and also with the consent of local people. Usually local people don't like when you go with some ideas. They feel like they know already what is good or what is bad, and our knowledge is probably not that accurate based on their experiences. So it is very, very, very important that we blend the scientific know-how with the traditional knowledge to get better ideas and also better programs where the knowledge can be implemented for the benefit of the society. Okay, that's all about the presentations we had in last 2 days. Then we had 2 brainstorming discussions with the team members and 1 brainstorming discussion with the regional team chairs, and several topics came up during those discussions. I think I will put 2 of them clearly here. One is the architecture. So what kind of architecture we are going to adopt for our forecast systems, and the indicators, what kind of indicator we should use. We have not identified indicators yet. I think Karina did a good job to give us some ideas, but at the moment we are not clear yet what will be our indicators. The idea was like to have some simplified indicators first, 2 or 3 simplified indicators first. And then probably using them, we come up with some results which can be useful to promote this activity in next 2-3 years. And then we also discussed about the architecture. I already touched on that, like the architecture A, architecture B, and architecture C. And I think we all agree that architecture A is the first thing to go with now. And then probably we will start using the digital twin, architecture B, when the digital twin will be available in next 2-3 years. And probably towards the end of the project or end of the decade, Ocean Decade program, the fully digital twin will be available to be implemented into the program. So start with architecture A, then go to architecture B, and then continue to architecture C. It doesn't mean that we abandon architecture A in between when we take the architecture B, because architecture A will have its own use and own operations, own operability. And we continue with architecture A and then adopt architecture B and then go to architecture C probably. That's the idea I think we discussed. Other points we discussed were like funding, where from we'll get the budget. As we know, this Ocean Decade DCC program doesn't have the essential budget to support all the teams and all the regions. So the idea was to pool the resources from all the teams, and then eventually when the funding comes, we'll decide how to use it and what will be our priority while using those budget. Then we also discussed about the capacity development. I think we had one idea like how to help the countries who are not so advanced in operational forecast activities. That's one way to do the capacity building. But during the regional chairs meeting, another idea came up that, okay, one way is to like provide the capacity to the not so advanced nations to build that kind of capacity there. The other one is to leverage the capacity what we have already in other countries. For example, if we have good resources in one country, which can be leveraged to another country, so that both can benefit from that, and through that we can enhance our forecasting system. So that is another way of capacity development. I think that's what came out during the discussions. Then how to connect with the other decade program. This was also a debate, and also we found the solution in that. I think what we believe is that not so many overlapping in our activities, and we have a very clear path from science to services. And other decade program may have some components of what we are doing. Wherever we see some kind of mutual interest or mutually inclusive activities, then we cooperate and try to enhance each other by not spending too much of resources from both sides, by sharing the resources. And we also had idea of like probably we use E2F as one of our topic to endorse through IOC and endorsed through other decade programs. And then we had some action plan. I think during the steering, during the brainstorming session with the steering team members, one idea was like we should have the calendar with the action plans. I'll come to that in a minute. I think the idea is at the end, we thought maybe we have a matrix of action plans and the teams. Before that, we need to match them, which team will be connected to which kind of action plans. And then we make the matrix. And in the matrix, we put the schedule. Okay, this activity can be done by this time. Then from one matrix, we have all the ideas like which action plans are being implemented in which region and which team is doing that, so that we can provide that information to the other regional teams so they can connect with these steering teams. And we also put the schedule so that we get the, we kind of try to target some time, give some time and get the results by that time. Okay, then, and then Enrique suggested like we take these 4 pillars and then put them into 10-point action plans. I think we already covered several of them, like do the mapping exercise. I showed you on this one. So do the mapping exercise. Enrique has many maps like that. So we'll pick up some of those maps and do the mappings. And then try to make the matrix based on those mappings, and then put the timelines so that we get the results and we know who is doing what and by what time we'll get what. And then he also had several action plans like contribute to the preparation of news. So we'll have so many news items and probably each team has some news, and then we gather them and compile them, if not once in a month, at least once in 2 months. And then we have the forums, as I discussed earlier. Then the forum can be used for both interaction among the researchers and also interaction between researcher and the stakeholders. So that forum will give us different ideas while helping the community, getting helped by the community, and also getting new ideas of what we should do to improve the forecasts. Then the virtual halls, some of them are already ready. We think probably we should improve on that, and that will be moved to the new homepage, as Enrique was saying. So once that is ready, maybe we can improve on that, add more information about each of those virtual halls, make it more interactive, I think. Then the other item was ocean forecast co-design team. So do the technical analysis, step 2 to 4 with the co-design team. And in that way, we can improve all of them. Then we have the contribute to the preparation of the tools and standard of the architecture. So the architecture already discussed. Architecture A, architecture B, and architecture C. To do those things, I think architecture A, already we have some of the tools, most of the tools, I think. But for architecture B and C, we need to prepare tools and standards. So data standards, as well as model standards, code standards, and what kind of data we are going to provide. So that kind of discussion should come in action item 6. Probably you should also have a timeline for these actions. These actions can be done this year, maybe the other action can be done the next year, and like that. Then contribute to the preparation of the regional indicators. So once we have those things, I think parallelly we can also work on the indicators. Not necessarily we should wait for all of them. I think we can start thinking of what kind of indicators should be helpful for this region, and also could be useful for other regions. And perhaps next year we should have some ideas about the indicators. Let's hope. And then we have the ETUFs, and ETUFs guides are getting ready. This will be one of, I think, good action item for us to get it done and get it endorsed by the other decade programs. Then connectivity between the ocean prediction DCC and the other decade action plans or other decade programs. As I said, ETUF guide could be one of the topic which we can bring to the other decade programs. Then the action item 10 is to develop and promote capacity. And we discussed a lot about that, both how to promote this activity and also how to develop the capacity, not only for other regions, but also between already existing frameworks. And these are the 10 action items, particularly, I think, envisioned by Enrique, and we discussed a lot about them, but we are also open to new ideas, which you feel is important for us to take into these action points. Then you can put them, if you agree on them, then you can put them to this 10 items or add to these 10 items. Okay, and then, as I said, we need to develop this metrics with different action items, different teams, and put the schedule there. I think this is one of the things we should start soon, probably towards the end of this year or early next year. Before is better, right? We can start as soon as possible. Maybe we can send, once we have a good metrics design, then you can send to each steering team, ask them which item is useful for you, and then put what timeline you want, and what are the resources you have, what are the additional resources you may need. Probably it's not available with the DCC, but maybe available with another region. Then we can kind of leverage that to get the benefit out of both regions. Yeah, how I'm doing with time? Done?
Maybe 5 to 10 minutes more and you're done.
Maybe
you want open the floor to.
Yes, I think it's better to, yes.
Okay.
I think so, yes. So that's all I think in my summary. Enrique, if you want to add something, please.
Oh, thank you. I think it was an excellent summary. Yes, to start discussing about this, I think we have to work in this matrix very, very fast, as early as next week, if we have the time for doing it. But it was very clarifying for us, the very open discussions that we have had related to these 10 action lines. These were well understood and well appreciated by members of the steering team and also by the chairs of the different regional teams. But of course, there are some difficulties associated with still some lack of funding. So we have to, when we are doing this matrix, we have to be realistic in putting priorities and putting timelines according to the resources that we have now. We are basically building large steering teams all in the different regions of the world. So we have a pretty decent capacity in terms of work, but it's only based on voluntary basis for the moment. So this is obviously a limitation that we will for sure overcome in the future. But for the moment, we have to be realistic and think on targets that we can achieve with the resources that we have. This can be easily expressed in the calendar that we will make associated to this table.
One thing I was wondering, like, can you put some of the indicators into this matrix, like action items or something?
I mean, an action item could be to support the design of these indicators, and
yes,
I think that that's an action there.
Yeah.
But this is going to be led by Karina, and we are in the best hands for that. So what we can do is try to influence on the decisions and try to provide data for the decisions to be good. We have a very clear message from previous Slido activity. Marine heat waves.
Yes.
It's a clear need everywhere. Okay, so I open the floor to the audience, both online and here. If you want to add something about, I think that Swadhin had a very good summary, but maybe there's something important that is left outside, or you want to comment something about, well, the floor is yours. We are in the wrap-up session, so if you want to add something.
Yeah, it might have discussed already, but concerning the capacity building, so training people in some state might be important, but at the same time, as Enrique said, training people is very hard. So another way of doing is, if some state has enough resources, they talk to some other country in capacity building and might better do some works for them. Like what's that? Find some indicators or find something they need, and some state might be able to provide information they need. One of the reasons why that's possible is we are running model covering many different areas. So sometimes we just look areas we are interested in, but if we expand our horizon or include opinions from other states, we might be able to produce information what they need. So I think that's another way of building capacity.
Yeah, one thing I missed here, like we discussed also to include PhD students, young researchers. So that could be one of the areas also for the capacity development together with the students. Yes.
I think it's important to understand that we are at the very beginning of building this DCC. We are this year building the regional teams. We are still in the process. This regional team is the most advanced one, and in fact is the one that is being used by us to brainstorm, to pave the way forward, which is very important. Other regional teams are still in the process of building the steering teams. There are many advances in the last week with respect to that. So I'm very confident that by the end of the year, all the regional teams will be in place. And we will have, thanks to these discussions this week, a well-tuned plan to proceed starting in 2024 with some specific activities. And I think that also the launch of the web page, also before the end of the year, if there are no additional surprise with the IT developments, will kick off the real action on the steering teams and on the regional teams. So, do we have any comment online, Vincent?
So, Fuji-san, you have any comments?
No, sorry.
Yeah, okay.
Yeah, I think it's a good summary.
Thank you.
It is indeed a very good job that you have. It was a difficult job to summarize 3 days of intense discussion, but you have done it really well. So we will close this session now before saying that all these sessions will be available on the Mercator Ocean YouTube channel. So those sessions are all of them recorded and they are available, which is, I think, of great value considering the very interesting presentation that we have seen covering all the different aspects of the value chain, from observations, modeling to today downstream service and marine litter. It was very, very nice session today also. So all of this will be recorded. Now we have to stop for some minutes because we are going to do a group picture here. And that will also give you some time for break at home, but we will reconvene in 15 minutes. So to have our last session, it will be very interesting because it will be led by the port where we are here today. We will have AZTI with us, which is an institution very important in Spain and Europe with respect to operational oceanography, and the facilities are here on the port. We will have Puertos del Estado with the forecasting services and monitoring services for the port as a very, very good example of downstream application and other things that you will see if you connect in 15 minutes for this final session. So thank you very much for being there and see you in 15 minutes. Bye-bye. We're good. Hello, everybody, and welcome to the last session of this event. We are closing the event with this session, and it's my pleasure to introduce this session because we will have very interesting local presentation. We will see, we will explore the activities of Albaola, of AZTI, and of the Port of Pasaia and Puertos del Estado, which are the main local authors for oceanography, operational forecasting, and history about navigation in the region. So it's my pleasure to start this section by introducing, giving the floor to Xabier, which is president and founder of Albaola. Xabier, please, the floor is yours.
Well, thank you very much for giving me this opportunity again to address to you. Yesterday, I had the opportunity to introduce to you Andrés de Urdaneta, which can be considered to be at the beginning of the oceanography research in the Pacific. You know, I told you yesterday how he was the one that found the return path from Asia, from the Philippines, all the way to Mexico. And this was a great achievement. And, you know, Andrés de Urdaneta, that he's not very well known, unfortunately, he deserves much more credit. He was born, you know, barely 40 kilometers from Pasaia, where we are now. And he's one of the greatest seafarers of universal maritime history. So, which we are very happy also is to have introduced you the San Juan, which is a galleon, 16th century galleon that was exactly, you know, very much like the one that was used by Urdaneta in this first Pacific crossing from west to east. So I think that maritime history, maritime heritage is very interesting nowadays because it's part of the history that connected the world, connected different cultures, and most of that history is forgotten, okay? So because of this Congress, because of the work we are achieving here in Albaola, we have the opportunity to highlight that past, and I think that is a great opportunity. So I'm very grateful for you to have chosen us to be here today. Thank you, to AZTI, to the Pasaia Port Authority. Thank you very much. And well, hopefully we will see you again, because as I told you yesterday, we are establishing very nice relationships with agents from Indonesia, also from Mexico. So it's very likely that our project might be seen over there in the Pacific again. So hopefully also, you know, China, India. We were discussing yesterday about, you know, some historical relationships, very interesting ones. And this relationship were made by the aim of sailing, by the aim of ships. And that's what we do. We revive that past, that technology. And well, I think it's a very, very interesting to combine it with a modern oceanography. I think it's a very nice combination. So thank you so much, and I see you next time. Okay, bye-bye.
Thank you very much, sir. Indeed, very, very interesting conversations yesterday.
Yes.
About things like even possibilities of why not trying to recover some ancient data and try to place this data in the framework of motion oceanography. There's a lot of possibilities, yeah. And I really hope that this visit, this idea of being Albaola, could trigger in the future some of your adventures, maybe, yeah. Around the world.
I like that.
And also some science, some good quality science, linking the past and the present.
Very good.
That will be great. So, historical oceanography, yeah. So, for the Western world, we learn from your presentation that the Basque and the Spanish sailors were discovering the currents. They were well known by Indonesian people at the time. We learn from Indonesian people. And that's exactly what we are doing during this week, learning from each other. So how we are continuing this tradition.
Thank you so much.
Thank you. So next presentation will be Susana Perez, former colleague and present day friend from mine. And she will introduce to all of us the work Puertos del Estado is doing in operational oceanography, especially serving the ports and more particularly serving the port of Pasaia. So Susana, the floor is yours.
Thank you very much. I'm going to share my screen. Can you see it? No, this is not the beginning, sorry. That's it. Can you see my screen?
Yes, yes.
Okay, thank you. Well, first of all, I want to thank you, the Pasaia Port Authority, and also Enrique and MacArthur Ocean for this opportunity to give this short presentation about what we do at Puertos del Estado. I'm Susana Perez. I'm part of the physical environment team in Puertos del Estado, and I'm going to give you a short overview about what we do in terms of operational oceanography at the service of the ports. You know that, I suppose that you already know that Spain has more than 7,000 kilometers of coastline. We have a lot of ports, and most of the transport, import, and export activity is done through the ports in Spain. So the port activity is vital for the Spanish economy. And at the same time, the ports are heavily exposed to the physical environment, to extreme events, especially caused by wind, waves, and sea level. And that's the reason why having good oceanographical and meteorological data is critical for the ports in any phase of life of these ports. Since the design phase, when viability or the budget and execution plans are organized, we need to have a good climatological description of the environment that can be done using models or measurements. To the construction phase, where for safety reasons, short-term and real-time information is very helpful to organize the progress of the works. And of course, in the final phase, in the exploitation phase, when the port is operating, we need real-time and short-term focus to generate warning services and tailored tools to help these exploitation operations in the port and the works that are done on a daily basis. Puertos del Estado has been working on operational oceanography since the 1980s, but in the last 10 years, we started with an initiative that we called SAMOA to give support on the daily activities of the ports, to develop oceanographic services, especially focused on the port's needs. This was done with three things in mind. First of all, we need real-time data. We plan to add new sensors at the ports to complement those that previously existed. Puertos del Estado has permanent in situ networks monitoring the sea at the atmosphere, and we plan to complement that within SAMOA. We also thought about developing daily services, forecasting services, very high resolution services to provide information of what's going to happen in the next coming days at the level of the port, and finally to create or develop tools and downstream services focused on the port's needs. That could be oil spill trajectory forecast, warning services, or overtopping warning services, etc. This is an overview of what we have. This is the in situ component that we have in Puertos del Estado, the stations that are now operating and transmitting real-time data. We have permanent networks of buoys, coastal and open ocean, tide gauges, HF radars, and of course, meteo stations, complemented with stations from the ports that they also have. And these stations are essential for the warning services and also for model validation or developing climatological studies. In the forecasting component, Puertos del Estado started also a long time ago with the regional scale focused services. We have a sea-level focus service that started in 1998 that Enrique knows very well. And wave-focused service that started in 1995 that provide daily forecasts. And parting from this, we in Samoa, what we did is to go to the coastal and local. We developed applications of downscaled model that are nested to these services or to Copernicus services to provide very high resolution applications at the ports. Today, we have 17 high resolution atmospheric systems that provide daily data with a resolution of 200 meters and 50 meters. We have 21 high resolution wave systems, which means in 21 ports, we have models that reach 5 meters resolution, that in 2 steps, starting from this regional system, we go to very local system with 5 meters of resolution in 21 ports. And similarly, in 2 steps, we starting from the Copernicus services, we go to very local high resolution circulation systems that provides current, salinity, and temperature, water temperature with 50-meter resolution in 31 ports every day. These services provide updated information once or twice a day. And with all these core data, what we did in Samoa is to develop tools and downstream services for ports to give added value to this information. I give you 3 examples here. Here you can see a snapshot of the oil spill tool that allows to generate trajectories of the evolution of an oil spill. That is available now in 31 ports and operating. This is the atmospheric dispersion service that allows users to generate simulations of the dispersion of some pollutants, atmospheric pollutants. It's available at 17 ports right now. And below you have a snapshot, an image of the service of overtopping focus that provides the risk of having overtopping events in the next 3 coming days, according to the wave forecasting services. And after all these years of work, since the beginning, going through Samoa to now, we can summarize all what we have in some big numbers that you can see here. We run on a daily basis 100 models every day to provide new data. We have almost 100 in situ stations operating in real time, providing real-time data. We have more than 2,000 users connected to the what we call CMA, that is the visualization tool that collects all the services developed within Samoa. And we send every day more than 800 alert emails and more than 200 SMS every day to users that subscribe to all these services that we developed in Samoa. We also sent summary reports to users to around 200 every day. And what for? I mean, how is all this information used by ports? Well, they use the operational oceanography services that we provide are used on a daily basis for decision making. That, for example, it could be to decide to close a port due to an extreme event that is being forecasted, or is a helping tool for piloting operations to getting ships in and out of the ports, to make daily operations safer and more efficient, to plan the works in certain activities like crane operations that can be affected by winds, or planning ro-ro operations. And of course, the environmental part is benefiting from these tools. For example, to fight against oil spills in the interior of the harbors, or controlling the water quality inside the harbors. And well, the port of Pasaia has been a colleague in this trip that's been Samoa, and that's ongoing already since the beginning. I'm going to show you the tool that compiles all this information that I mentioned before. This is the CMA, that stands for Cuadro de Mando Ambiental, that can be translated like environmental control panel or something like that. Each harbor that is cooperating in Samoa has one of these tools. You can see here all the ports that have it. There are 44 ports having a Samoa environmental panel right now. This is the one in Pasaia Port that has a port summary. The idea of this is having everything, the core information collected in one page.
Susana, no sé si nos estás enseñando el CMA, pero no lo vemos todo.
We are not sharing. Okay.
No, estamos.
Yes, I was. Okay. Let me check. Okay.
Maybe you share the PowerPoint instead of sharing.
Yes. That's it. I'm changing. Are you watching now?
Now it's perfect. Thank you.
Okay. This is the CMA. I was saying that it's available in 44 ports. These are the list of ports. I have access to all of them, but it depends on the port. The access is different. Every tool is managed by the port itself. They have nominated people to become administrators of the tool, and they grant access to the tool or to the different sections. They can also define alerts in terms of the awareness services and define thresholds. This is the Pasaia Port, as I mentioned. It has a summary that summarizes everything in one screen, which means this is a summary, very simple in terms of icons of the real-time information, the latest data, and the focused information in the next 3 coming days, waves, wind, and sea level, the highs and the lows for the next coming days, the hours, the forecasted maps, animated maps of all the parameters available, the same thing, forecasted information in time series. Here, animated time series. They can be zoom in and zoom out of all the parameters. I mean, waves, sea level, wind, current, salinity. The same thing for real-time data available in one page. All the core informations, and then the specific sections that have the application. This is the measure station, the in situ data information. In this case, in Pasaia, we have two stations, a buoy that is providing waves and water temperature. We have here the latest data received from 9 a.m. UTC time. the icons change its color according to thresholds that users can define. I have my thresholds defined here. And according to those thresholds, I'm in a yellow level. It's like a traffic lights color. I mean, it can go into green, yellow, and red. We can open time series plots where the icons, the thresholds are also shown. They are animated. Users can go backwards and forward. And then here we have the sea level and also the agitation that these sensors, this packages also gets the very local waves data. And also it has additionally an atmospheric station that was installed within Samoa in the past years. And the forecast information has several sections. The information can be accessed in different ways. We have information for some set of points that have been defined by the port authority, have been decided in which locations they want to have this information. Users can check these points, the latest data, clicking on them, of wind, waves, and currents in this case. As you can see, new icons, again, icons that change its color according to thresholds. We can see the maximums each day, and we can also open time series where the thresholds are shown too, that are animated also. It can be printed, whatever. And here we have in the anchor icon, we have the sea level focused information, which means we have the maximums every day and the lows and the highs for the next 3 coming days. We can open also plots, time series plots, where we overlay also the tide gauge data as a validation of the forecast. Additionally, the forecast information can be consulted as maps, by means of maps, animated maps of the next coming days. This is the waves maps in Pasaia. We also have the currents maps from the model, the latest maps of that was released last night. They are animated, and we overlay animated particles at every time step. And the temperature of the water temperature for the next coming days, animated maps. And Pasaia has additionally one of these added value modules that we have developed in Samoa, that is the oil speed trajectory forecast service. This allows users to create trajectories, which means I have one that I prepared before. I'm going to show you. Users just go to a menu and they can configure the simulation, the starting dates, the duration, where is it located. We can click on the map to say if is it instantaneous or continuous spill. Of course, establishing the kind of hydrocarbon that's been detected or spilled, and these models are forced and based or rely on our currents and atmospheric forecasting services, and we can select which one of the services we can use for the simulation. And when we have all fulfilled, we can simulate. It takes no more than 5 minutes or 2 minutes. Generally, it's a couple of minutes, no more. It depends on the configuration we had made, the time steps, etc. It's loading the simulation. And now we have it. We can see here the evolution of the spill that is supposed to be located initially here and is evolving. We can overlay the surface currents or the waves surface maps. And we can see here that the spill that started, it ends colliding to the dock outside the river, but part of it is getting inside the river. and gets to this side of the coast. And well, I don't know if I go back to the presentation, you will see, but that was all basically what I wanted to say. Thank you very much for your attention. I don't know if there's time for questions, and if not, you can write me an email and ask me any doubts or comments you can make. And thank you very much. That's all.
Thank you very much.
I don't know if it was too long or too short.
It was perfect, Susana, perfect in time, perfect in contents, as always. So is there any question for Susana on the audience? I think you were too clear. You want to? Mari is having one question for you.
I have, this is my email. I hope you can see it now. If you want to write me an email, it's perfect too. Yes, please.
Thank you, Susana. That was really very nice. And I was just wondering, these applications are made for Spanish ports, but is there a plan to work on a public application with simplified functionalities for the general public, or?
You mean to adapt this to another site, another place?
Or to make this knowledge available for a larger public in Spain? Or?
Well, it's I mean, the application, the application that compiles all the information has to be accessed by user and password, but the people from the ports, I mean, anyone can ask for an access, and it's the administrators from the ports who give that access. And as far as I know, it's rarely that they deny an access to any person. It's not for the port community or the.
So Susana, maybe Susana, you can complement this with just a little bit of information about the Portus system, which is really open for the society.
Yes.
And the impact that the Portus system have on Spanish society. You can talk a little bit about that.
Yes, for sure. Let me share then the screen of my. Yes, this is a tool more focused on ports, but what I wanted to mention is that the access is not closed or strictly closed for the port community. Any local authority. I know that, for example, in Asturias, the regional government have access to the tool because they use the information that we provide there. This is our general webpage, where basically most of the information is also available here. We have focused available here, the real-time data stations, not only ours, we also added European stations are available. Access is open in this case. We can go to Pasaia. You can see that there you can see the tide gauge and also the buoy. We have the information in form of tables and plots also. The time series tables and plots are available. Basically, and this is open. This is open, and we have more than 2,000 users every day. We have our forecasts too. Let me see that changes, uploads everything. The maps, also the table, I mean the points, the information accessed in form of certain points where plots and tables can be shown. Tables that summarize the latest data of the latest forecast for the next coming days.
Thank you, Susana. I think that maybe something it would be good if you can share in in the chat the address of the
Okay.
CMA
Yes, of
and the address
course.
of both addresses, CMA and Porto, so people can connect and explore by themselves.
Okay.
So
Perfect.
thank you very much, Susana. It was fantastic to hear you here explaining all this work. And
It was a pity that I couldn't go,
it was indeed.
not to be there in person.
It was indeed. And next speaker is going to be Julien from, I think, this mic or Julien Mather from AZTI is the head of the oceanography team on AZTI. And AZTI is located in the Pasaia Port, so luckily he can be with us without much effort. And he will present us all about the activities they are carrying out. Thank you, Julien. Susana, can you please stop sharing?
Yes.
Thank you. Is it okay? Are you hearing me? So thank you very much, Enrique. So thank you from the OceanPrediction DCC for this invitation. Thank you for the Port Authority for including us in this session. So I will be a bit forward from the ocean modeling, but it's something very related with different actors here in the Bay of Pasaia, with the local agency for economical development, with the port, and with AZTI, that is so an applied research technological center. We are promoting different initiatives for developing new opportunities in the context of the blue economy. And I will present a bit more about what we call Pasaia Marine Smart Technology and Business Center related with ocean monitoring and ocean observations. So as has been presented before, there is a very important link to the sea in this specific region, in this specific port. You have seen what Albaola is doing and all the history that is important, that was important and is still important in the local economy. So with this new Warsaw-Aldea Blue Hub, we want to position the Bay of Pasaia as a blue economy development brand to promote these kind of initiatives. And we want in particular to promote different work lines from a competitive technological space, using technology and science as a base for developing those initiatives, in general related to face global challenges as climate change or new opportunities related with a more circular economy. So as I mentioned, AZTI is working on marine science and food science. We are a technology center, and we have one of our 3 headquarters here based in the port. Just to show you, so we are there. Actually, I think people from here, you took the boat every morning quite close from AZTI, and we are here in Albaola. So how to go from global challenges that you are dealing with in those DCC and with these global initiatives until local opportunities related to blue economy. So we define cross-cutting axes that are common to a lot of us: sustainability and digitalization. So AZTI, together with Warsaw, the agency, together with the port, we try to find between public institutions and private companies, we try to define first transformating projects to start working in different work lines. We define, so with the landscape and actors we had, we defined the first 5 lines of work. The first one is related with electrification of ports, mass grid, cold mining. Second one is more related with Pasaia Smart Bed, ocean observation, and we'll detail a little bit that. The third one is new opportunities for naval engineering. So this one. New opportunities for naval engineering, developing floating platforms. The third one is related with biotechnology, the use of marine ingredients. And the first one is for the food industry, so new products from companies installed here. So about this Pasaia Marine Smart infrastructure, we want to integrate different components. The first one is technological incubator, trying to integrate new platform from ocean observations with local actors, local providers, local companies, to put in place new ocean observing services, and to use the area as a test and validation zone. So we define a marine observation infrastructure specialized in the use of autonomous vehicles and the use of marine technologies. So I will describe a bit more the glider port we are putting in place, the use of unmanned surface vehicles, and the use of coastal videometry. So in Spain, before that, we had only glider ports in Canary Islands and Balearic Islands, so nothing relevant in the Bay of Biscay. Actually, also in France, it's not so used. So we put in place this glider port with the focus of all the Bay of Biscay, and we start using this technology. There are autonomous vehicles able to glide in the water column. So as an example, the first mission we performed last year had a focus on interdisciplinarity. We use a glider with an echo sonder to be able to acquire some information about the distribution and abundance of fishes. And we compare, so the special scientific study was to study the impact of a storm on the distribution. The idea was to compare and to complement the typical information we are trying from fishing vessels and oceanographic vessels. So here in this graph, so I will go quickly, but we are comparing the information from the boat and from the glider before and after the storm. So it's a very interesting information for our colleagues from that are marine biologists to see and to take into account all the effect of those environmental factors in the management of the stocks and the forecasting of the recruitment. So the second important part is working with a local company called Branca that is developing this kind of autonomous vehicles. We work on a base of operations here in Pasaia, where we will be able to operate this kind of vehicles. And the first unit has been also equipped with some echo sonder to be able to have remote information from this autonomic vehicle. So we are working with the Port Authority, but also with the legal entity here, Capitania. I don't know in English exactly what is, to also study how we could operate in the future this kind of new platforms. And the third technology is coastal videometry. So we have more experience from the past on that. The first unit we installed in the coast is for monitoring beaches, so from different cameras installed in the coast. But there is plenty of application for services on beaches linked with modeling capacities that we are developing. So we could monitor through some index, so long-term and climate change impact on the coast, some near real-time wave overtopping also monitoring to complement the modeling capacities shown by Susana before, actually. We're also able to integrate the information from the video station in some modeling configurations to forecast the rip currents and sending all the information to the people dealing with safety in the beaches during the summer. For beach management, but especially in the COVID period, we put in place some tools for monitor also the user density in the different beaches. And all that based. So in this smart bay context, we install a new station in the entrance of the port of Pasaia. So this is the image we can receive from this application. So it's providing information for the Port Authority and the pilots in near real time. And we will work. So this is a typical tool we can have. In that case, it's not so interesting because there is not important infrastructure, but we can follow the impact of the waves, let's say, on the lights in the entrance. But the idea is also to work on validating some wave parameters analysis from the video that we are working on. And here we have a automatic monitoring of all the wave overtopping on port infrastructure or other urban infrastructure in other places. So all the research part of this coastal video memory stuff is performed in this cross-border lab that we have with the University of Po and with the private company Swadhin, with the Rivage Protect team of Swadhin. So we are joining the videometric capacities with modeling capacities to forecast overtopping in sensitive infrastructure. So future next steps a little bit. So we want to consolidate this Pasaia Marine Smart Technology and Business Center, attracting new funding and initiatives around the ocean observations, to increase the portfolio of existing technological companies, and to still work on digitalization and to transfer those technology in the different maritime sectors, helping and supporting also the evolution of the smart port in Pasaia. We want to create more, we have, but we are also working on international links with other smart bays, other important institutions on observing networks. We want to have also an impact in the regional operational oceanography network connected to the Copernicus capacities also here in the Basque Country. So from all those new ocean observation capabilities. And that's it. Thank you for your attention.
Thank you very much, Julien, for this fantastic presentation on all the very different capabilities and all the different new initiatives that you are carrying out. And if you have any question.
Thank you. Your presentation is wonderful. So I just wonder, so the glider data and the autonomous vessel data is real time to collect in your smart system.
So if we are able to receive in near real time the data?
Yes, the real time data. So how about the delay time, 1 hour or more?
So we are, in both cases, we are able to receive part of the information in near real time.
Okay.
For glider, there is an energy consumption issue. Mm-hmm. So we are only sending part of the information in near real time by satellite communications, and just to guide the design of the mission. So we receive obviously the position of the glider and also a summary, let's say, part of the data that the sensors are acquiring. Then in the middle, it's a bit more powerful because we have a direct link with the boat, a broadband communication, and we are able to be connected to the PC, to the computers that are on board. So we have a direct access to all the software that are controlling the sensors.
Okay, thank you. Thank you.
You're welcome.
So, any additional question?
Hi, I just noticed that you have a very, very beautiful visualization of a wave overtopping the coastal areas. So it's based on the model result, or it's just you know,
the animation, you mean?
Yeah.
This animation was made, yes, based on model outputs. Yes. So we try to work. It's the objective there. It's sensibilization of the general public on the impact of this kind of storms. The problem is that all the people, they would like to see the big waves when there is a storm, so they're approaching those areas where it's quite dangerous to be. So we would like to put in place, related with the different traffic lights, informing about the level of risk during a specific events. We would like to have this kind of different view of what could be the storm and the overtopping for the different level of risks.
So is there any storm surge in winter in the area? Storm surge?
Storm, yeah, it's quite, so here it's quite typical. So here in this specific place, it's more related with agitation and long waves, because we are quite well protected in the inner part, but close in San Sebastian and in other cities along the Basque Coast, we have a lot of problems of damages caused by these overtopping waves.
Thank you.
I have also, Julien, one question online for you. Do you have an idea of the accuracy of the vessel measurements?
You mean the sensors that are on board in the vessel?
I guess so.
So the first, so this vessel will be used as a platform for testing sensors and validating the use of this kind of vessel. So in this first configuration, we install scientific echo sonders. So they are quite good for that. I'm not a specialist in acoustic, so I'm not in mind the exact type or characteristics of those echo sonders, but they are the best sensors we can have in this specific.
I can imagine the person asking the question I can imagine is referring on because of these sensors are in a boat instead of being in another place. If there is an impact about that, do you have an idea? I guess this is.
The point is that those sensors are used to be installed in boats, in oceanographic vessels,
in floating platforms.
Yes.
Or in boats.
So that's true that maybe this relatively small boat, it's a 6-meter boat, will have a different behavior than a big boat. So we have to be aware of that. But we are starting the test. So we didn't study yet first data from this boat.
Okay, I have a question for you. From your experience after starting with gliders, to what degree do you think the technology is mature enough in terms of being a powerful observation system? I mean, I know that gliders are consuming a lot of resources in terms of human resources needed to navigate the gliders, and also a lot of resources in terms of maintenance. After, let's say, sorry for the word, playing a little bit with the gliders, what is your feeling about how strong is the technology to be a real asset for monitoring in the ocean today?
Actually, in our team in AZTI, so we are relatively small teams compared to big oceanographic centers. So we were a bit waiting for better solutions from the glider providers. And for the gliders we have from the Alcimar company, actually it's a French company, they are offering the gliders, but also a kind of general maintenance of the gliders. So we have some modules, and our technical team is able to change the sensors, for example, and make a kind of basic maintenance of the equipment. But every, I think, 3 or 4 years, we are sending back the gliders to this provider, and they are performing the general maintenance. I think it's opening the floor to smaller institutes to use these technologies. And in terms of piloting, you're right that I think we have to put more effort on coordinating teams in a same country like Spain, but also in Europe, to share the effort on piloting gliders, because one single pilot can pilot different gliders from AZTI, from SOTIP, from Plocan, or other institute in Spain. So I'm sure in Europe and in the world, the glider community is working also in sharing the effort for
so when we are talking about things in Europe like EOS, that could be a perfect target for that. Yeah, that's very good. Thank you.
So in a continuous operation, how long these gliders and the boats you can use?
At sea?
Continuously if you're
so
at sea, yes.
With this glider, we can have a 20-25 days campaign. So we have to recover the glider every 25 days, more or less. Then it depends a bit on the sensors we have on board and the frequency of the acquisition you have, but more or less the targeted mission is around 20-25 days.
Okay. And nowadays they use AI to operate those gliders and also the boats, autonomous boats. So you have AI on them?
Not for piloting the the glider. That's true that it's quite autonomous. So you could design all from the very beginning, but then we have to take into account the impact of the currents that you try to predict, but it's not exactly the impact that you were able to forecast. So for safety of the equipment, we need someone to take care on it.
Okay, thank you.
Okay, thank you very much, Julien. We have to move to our next and final presentation. Speech. David will close the event with some words about the port. Thank you. David is the Director of the Port of Pasaia.
Yeah, well, thank you. And I have to start apologizing for my low level of English, so you have to excuse me. I'll try to speak shortly and clearly. Well, you have here for 2-3 days, not maybe all of the week, I don't know. So the people that you are here, you know, not just perfectly, but shortly Pasaia. And as Xabier explains, Susana and Julien is and 3 examples of the past, present, and future of the port. Albaola is I think the best example of how the Pasaia port becomes the existing century. As Xabier always say, the Cape Cañaveral of the Europe, I think the place where the rockets start and go to find another new countries and so on. So it's it becomes a Pasaia in a very, very important point of knowledge and so on in Europe in this data. At time and today we heard Port of Spain, Puertos del Estado, Susana has explained us how the knowledge of I think better say this the technology that the Puertos del Estado becomes to know all of the measures of oceanic measures is a very, very important and I think in Europe and very in the top of the technology, I think, and it's an example from how Pasaia Port or the Port of Pasaia have the very, very good technology from this partner case, this Puertos del Estado. And AZTI, Julien says, is I think a good example also of the future of the port, maybe vinculated with blue economy and how it is becoming a very, very important way of increasing, not only have a bigger size or so on. As I say, usually are in Spain or Europe are provided a more bigger center of technology, but we are very, very proud to having AZTI here in our port and the services that AZTI belongs to community, not only Pasaia Port, only the country, the local country, the local government. So we are very proud. So it's I think a good example of how this port, Pasaia Port, has a good examples for past, present, and future, how we are like our role of port authority, given the area or the conditions to have this type of services or services. Yeah, is maybe the better name of this. So I don't want to be in here speaking more time than necessary. Thank you to Enrique for having thought in Pasaia, and we thinking that it will be a good place to having this meeting. So we are very proud of having you here, and hope you see in another occasion here in Pasaia. Invited here. Okay, thank you.
Thank you very much. So thank you very much, David. It was certainly a privilege for me to be back in Pasaia. And I want to close this week by thanking many people. For sure, I will forget something. Sorry for the ones I forget. I want to start with all the speakers and with all the online participants that were patient, staying with us all these hours, listening to what we had to say. Certainly, I want to continue with Vincent. As always, he has solved all the problems and he has solved everything, as well as the administration of Mercator Ocean that had not the opportunity to stay with us. So I want a big applause for Vincent and the other crew of Mercator. Then I would like to highlight the excellent catering and Izaskun that has been very nicely serving us. And Nara was great supporting all of us from the very beginning. So thank you very much, Nara, for all the work you have done for make this real, for keeping us with the heating perfect, healthy here. And so thank you. And of course, my big thanks for Albaola and the port for hosting us here. It was really a pleasure to be in these fantastic installations, to be in this fantastic place in Pasaia, in San Sebastián, enjoying the city, enjoying the pinchos during the night. It was absolutely great. It was wonderful to connect with the history of navigation here at Pasaia, to understand how we connect our past with the present, our past of navigation, of discovering currents, of discovering, doing science somehow also with the science we are doing today, and connecting in the same exact way that we are doing with this DCC Collaborative Center. So thank you for all of you that are connected and still saying things online. And it's my pleasure to close now. I invite you, all of the people here, to have some lunch with us, if it's possible, if you have the time. And thank you very much. Goodbye, and see you next time.